Hello and welcome to adding and subtracting algebraic fractions, and this topic is more complicated problems. So our previous lesson was on pretty basic addition and subtraction of algebraic fractions. This time we're going to look at algebraic fractions that have numerators and denominators that are much more complex. So they have more terms versus just an x or any other singular variable. But before we do it, I want you to work a couple of example problems that might help you with our problems for the lesson. So the first problem is a problem on simplifying algebraic fractions. Here's the problem. 2x squared plus 6x over x squared plus 7x plus 12. I'd like for you to simplify this fraction by factoring. Remember, you factor the numerator and the denominator, and then you look for any common factors that you can cancel. So take a moment, press pause, and try and simplify this fraction on your own. And when you press play, I will give you the answer, and then you'll have an opportunity to see an explanation of the answer. The answer to the problem, as you can see in the top right screen, is 2x over x plus 4. If this is the answer that you got, great. You can fast forward to the next problem. If you would like to see an explanation of it, then hang on. So I'm going to take my fraction and look at the numerator and denominator separately. Start with 2x squared plus 6x. We want to factor that expression, and when I look at those two terms, you always first want to look for a GCF, and in fact this one does have a GCF. The GCF is 2x. So I'm going to put that out front and then open up a set of parentheses. 2x squared divided by 2x is just x, and then 6x divided by 2x is 3. After you take out the GCF, look at your remaining expression and try to determine if you can factor it some more. Well, the remaining expression is x plus 3, so that's not a difference of two squares. It's not a trinomial. You can't use grouping. We're done. All right, moving on to the denominator. It's a trinomial, and it's a quadratic trinomial. Quadratic trinomials are the ones that we want to factor into a product of two binomials. And since my lead coefficient is 1, these are pretty simple to factor. I'm going to start by opening up a set of parentheses, and then I'm going to fill in an x and an x. The only work you have to do is you have to look at the last term, positive 12, and see if there are any factors of positive 12 that have a sum of positive 7. And in this case, it would be positive 3 and positive 4. So the factors of the trinomial are x plus 3 times x plus 4. Now that we've factored both the numerator and denominator, then compare the two and look for any common factors that will cancel. In this case, my common factors are x plus 3 over x plus 3. So I cancel those out, and what's remaining is 2x over x plus 4. There's my final answer. The next review problem I'd like for you to work is a review from the previous day's lesson, and it's a simple addition problem with algebraic fractions. 2 over 3x plus 5 over 2x squared. Press pause, take a few minutes, and work the problem, and then when you're ready to check your answer, press play. Alright, so hopefully you got 4x plus 15 over 6x squared as your final answer. If you did, great. You can move on to the lesson. If not, why don't you keep watching and see if you can pinpoint what your mistake was. For 2 over 3x plus 5 over 2x squared, I had to identify a least common denominator. So I'm going to write it off to the side, my LCD. My two denominators are 3x and 2x squared. So I know my LCD needs to include the least common multiple of 3 and 2, which is 6. And then it has x as a factor. Well, the maximum number of x's that they have in common is x squared. So that needs to be in my LCD. And there you go. The least common denominator is 6x squared. So we're going to have to change both of these add-ins. I'm going to take 2 over 3x, and I'm going to multiply it by 2x, because that's what's going to give me 3x squared. I'm also going to take 5 over 2x squared and multiply it by 3 over 3. And that will give me the 6x squared. So we'll have 4x over 6x squared plus 15 over 6x squared. And when I combine those, all of this is going to be over 6x squared. And then the numerators, that 4x plus 15, those aren't like terms, so I'll just write the numerator as 4x plus 15. Okay, there are no common factors that I could have factored out and then canceled, so I'm done. 4x plus 15 over 6x squared. You really need to be good at simplifying algebraic fractions, because you're going to see problems coming up where after you add or subtract the algebraic fractions, you may need to take it a step further and simplify. So let's move on. The first type of problem you'll see is expressions where, or numerators that have entire expressions in them. And what I mean by that is saying this is an x minus 1. It's a multiple term expression. But the steps are the same. Look at your two denominators, 12 and 4. The least common denominator between 12 and 4 is 12. So I can leave x over 12 alone, and then I'm going to take x minus 1 over 4 and multiply it by 3 over 3. This is the tricky part. When you multiply the numerators, go ahead and expand. I'll make a little note for you. Expand the numerator. So that would be, we'll keep your x over 12. And when I expand this numerator, I'm going to distribute 3 to x and negative 1. So that would be 3x minus 3 over 12. Now that we've done that, we can combine these over the like denominator 12. And then you look at the two numerators. We're going to add these two together and collect like terms wherever you can. So when this x plus 3x, those two can combine to become 4x. And then we have plus negative 3. Well, plus negative 3 is minus 3. Once we've done this, there's nothing else that will simplify. 4x minus 3 doesn't factor any further, so I can't cancel out that 4 over the 12 or the 3 over the 12. Leave it alone. Your final answer is 4x minus 3 over 12. All right, our next problem is a subtraction problem. Start off by identifying the least common denominator, and in this case, since our denominators are 3 and 7, I can pretty easily identify the least common denominator as 21. So I'm going to take x minus 1 over 3 and multiply it by 7 over 7. Keep your minus sign. And then I'm going to multiply x plus 2 over 7 by 3 over 3. So again, expand the numerators. We're going to start by distributing 7 to x minus 1. So that would be 7x minus 7 over 21 minus, I'll keep my 21 there, and I'll distribute again here. 3 is distributed to x and 2, so that's 3x plus 6. When you're subtracting fractions, you have to be very careful. This is a very common mistake that I see people make because they're not realizing that you have to subtract everything in that numerator. So watch me do it. I'm going to go ahead and put 21 in my denominator. And I'm going to start by reminding myself that this negative gets distributed to 3x and to 6. And so my like terms, I have 7x minus 3x. So 7x minus 3x is 4x. Then I'm going to do negative 7. And I erase my minus, let me put it back. Negative 7 minus positive 6. Remember, you're distributing the negative. Negative 7 minus positive 6 is negative 13. Now we've properly combined the numerators. And our answer would be 4x minus 13 over 21. Okay, you try this on your own. I have an addition problem for you. It's x plus 1 over 2 plus 2 minus x over 7. Press pause, take a few minutes, and try to answer this on your own, and then I'll give you the answer when you come back. If you work the problem correctly, you got 5x plus 11 over 14 as your answer. If this is the answer you got, go ahead, fast forward to the next problem. Great. If not, stick around and watch me work the problem. 2 and 7 have a least common multiple of 14, so that also means my least common denominator is going to be 14. So I'm going to multiply x plus 1, it's like a 7, so x plus 1 over 2 by 7 over 7, plus 2 minus x over 7 by 2 over 2, and don't forget that you're distributing, so putting parentheses around those numerators helps. Alright, the first fraction over 14 is going to be 7x plus 7, and then plus. The second fraction over 14 is going to be, we'll distribute the 2, so 4 minus 2x. Now we can combine. So I'll go ahead and put my denominator there as 14. And collect your like terms. 7x plus negative 2x is 5x. And then 7 plus 4 is 11. That's how we get our answer, 5x plus 11 over 14. All right, let's move on to the next topic. Expressions in the denominator. So the previous problems had real numbers as your denominators, like 2 and 7, 3 and 6, and it's pretty straightforward to find the least common denominator. It's a little more challenging when you have variables in your denominator, but if you understand the principle of the previous problems and how to find the common denominator, you should be fine finding the common denominator of these new problems. So our first example is 2 over x plus 1 over x plus 2. You need to identify the least common denominator. And in this case, since our factors are x and x plus 2, the only common denominator we can identify is going to be x times x plus 2. It's just multiplying the two together. So I start by taking 2 over x, and I'm going to multiply it by x plus 2 over x plus 2 plus 1 over x plus 2, and I'm going to multiply it by x over x. All right, this is the tricky part, and I want you to make note of this. When you simplify these problems, you always need to expand the numerators. The denominators are a little different. You can expand them if you want to. So you can make your denominators x squared plus 2x, but honestly, you don't have to. In fact, if you leave the denominators factored, it's less work for you. So I'm going to say expand the numerators, but leave the denominators factored. So this next line will show you what I mean by that. My denominator, x times x plus 2, I'm going to leave it as x times x plus 2. I'm not going to distribute anything. But the numerator, 2 times x plus 2, I need to expand that. So I'm going to make it 2x plus 4. Okay, and then I do it again for the second fraction. I'm going to leave the denominator in factored form, and then I'm going to expand the numerator. So 1 times x is x. Now that we've done that, again, I'm leaving the denominator in factored form, and then I'm going to collect like terms in the numerator. So 2x plus x is 3x, and then plus 4. Once you've combined them, check your numerator and see if it factors. In this case, it doesn't factor. 3x plus 4 does not have a GCF. It's not a special polynomial. So there are no common factors to cancel out here. But you always want to check because you will see problems later on that do simplify. All right, this is the end of part 1. Go ahead and watch part 2 and continue on with your notes.